Wait a minute. Is my screen visible, ma?
Yes, ma'am.
Yes, ma'am.
Okay. So the first question, let R0 be the register and M0 be the memory location. Consider the following two instructions. So memory location, the value at the memory location pointed by the register 0 is copied into R0. And copying the contents of R0 to M0. So identify the correct statements about the above instructions. So this reflects, so the value of memory location you are loading into the register. Okay, so when you are copying some value from a memory location to the register, that operation we call it as a load. You are loading the value from a memory location to one of the internal registers of your CPU. So this is called the load operation. Now we had some value in our register that you want to store it into a memory location. So that is called store. So among the given options, the instruction 1 is the load operation, whereas the instruction 2 is the store operation. Okay. Which component of computer system is responsible for non-volatile storage of data and programs? So non-volatile means even the power is off, the data will not be
For a
erased.
long time.
Yeah, the data will not be erased even the power is off. Okay, so such a, see, main memory, you will lose the data once you terminate the execution of your program. Okay.
Ma'am, so non-volatile memory means which is stored permanently, no?
Yeah, non-volatile means
Okay.
if any, suppose power is off, your system power is off, then it won't erase the memory. Volatile means once the power is off, it will erase. Non-volatile means it will store permanently. Okay.
Okay, ma'am.
So
Okay.
so in suppose if you take a main memory, how long it will retain the data? Till you terminate your program execution. So once we load the once we start the execution of the program, the data related to that program will be there in the main memory. Then only you can able to execute. Once we terminate the execution of the program, the whatever data that is stored in your main memory will be lost. Okay. So when you load the another program for execution, the data related to that program will be again loaded into the main memory. So it can retain the data only till the execution of the program. Once we terminate the execution, it will be lost. Okay. Central processing unit, it won't store the memory. It is responsible for executing or controlling all your components. So the secondary memory is something like your hard disk, which, yeah, so SSD or hard disk. So where you can store your files permanently. Today, if you store some file, tomorrow also you can able to access that file. Okay. So even though you power off your system and tomorrow if you switch on your system, it won't be lost. Okay. So that memory is called non-volatile. Volatile means once we terminate, it will lose.
Yeah,
okay.
It is after the ending of the task.
Yeah. Main memory is the volatile, whereas the secondary memory is the non-volatile. Which of the following are examples of secondary storage devices in the computer system? So your hard disk, hard drive, or your nowadays in the new systems you are getting SSD, solid state drives, and your pen drives, USB drive. To the USB drive, you can connect your external devices like your pen drive or your external hard disk. Okay, so all those are the secondary storage memories, whereas a RAM is a main memory. Registers are the part of your CPU, like your processor. Cache memory is also, it will be between the main memory and the fastest memory, you can say. So the frequently executed instructions will be there in the cache memory, so that it can able to execute the instruction fastly. Okay, so that is also RAM type of memory only. So only the first three are the secondary storage memories, whereas all these are volatile. All these three are volatile. How many bits are required to encode the string IITM using a 7-bit ASCII? So the 7-bit ASCII, so generally we represent the data using ASCII format. Like suppose if you enter some integer or something, say suppose 10. So first it will be converted into binary, and the binary bits, how many bits are required to represent 10, that is represented using those many bits. Whereas a character, each character, for representing each character, we require 1 byte of memory. In general, we require 1 byte of memory. So here we are asked using 7-bit ASCII. So that means for representing each character, we require 7 bits. So there are 4 characters in this IITM. There are 4 characters in this. So 4 into 7, 28 bits are required to store, to encode this particular string.
Ma'am, what is the ASCII mean?
American Standard Code for Information Interchange. Like for every data, say suppose we know the language when we use your words using your alphabets, English alphabets, either small a to z, small a to z, or capital A to z, okay, or digits. But this language cannot be understood by your computer. This language cannot be understood. So this is something which is formed using these alphabets, digits. It is called the high level language. Whereas this language cannot be understood by your computer. Computer can understand only the binary language. So it will be in the form of ones and zeros. everything, whatever you want to say, add these two values. So you have to say that instruction also in the form of ones and zeros, okay, to the computer. So to convert the language which we are using into the language which can be understood by your computer, so some translator will be there in between, so which will translate the characters which we are giving into a binary format using some code. Okay, so
Okay.
that code is nothing but this ASCII code. So there are so many codes are available. So one of the famous and most of the languages that use most of the compilers that use this language is the ASCII, American Standard Code for information interchange. So
And one character uses 7-bit.
yeah, how it, not one character uses 7-bit. Here in general, how many different digits are accepted by your language? Okay, based on that they will define the ASCII values. Okay, suppose
Okay.
how many different symbols we have in the language. Say A to Z means 26, small a to Z
Yes.
another 26, 0 to 9 another 10, and we have a punctuation marks like comma, dot, like that you'll have. So if you take the data, say one bit of data, so it can able to represent only two different values. So that bit can be 0 or that bit can be 1. So only two different values it can able to represent if we take one bit. Okay, suppose if we take two bits, so 0 0 0 1 1 0 1 1, four different values it can able to represent. When you take two bits of memory, so the two bits can able to distinguish only four different values. Okay,
Okay.
suppose if we take three bits, 0 0 0 0 0 1, so like that it can able to represent values up to 8 different values, or simply we can say 2 power n values it can able to represent, where n is the number of bits that we are using. Suppose
Okay.
if we are using 3 bits, 2 power 3, so which is equal to 8 bits. Suppose we are using a 4 bits, 2 power 4, 16 different values.
16-bit. Yes.
So like that, suppose if I take 1 byte of data, one byte means 8 bits. 8 bits is called 1 byte.
Yes.
So we can represent 2 power 8 different values. 2 power 8 different values. So 2 power 8 is nothing but 1024. Isn't it? Wait.
Yes. Yes.
Okay. Yeah, 1, 2, 4, 8, 16, 32, 64, 128, 256. So how many bits? If you take 1 bit, you get 2 power 2 power 1. So two different values. 2 bits means 4.
2 power 4.
Sorry. Not 1. 2 power 0 is 1. Suppose if we take 1 bit, it will be two different values. 2 bits,
Yes.
4. 3 bits, 8. 4 bits, 16. 5 bits, 32. Okay. 6 bits, 64. 7 bits, 120. So we can able to represent 256 different values if we represent 1 byte of data. To represent, if you take a memory of 1 byte, how many different symbols you can able to identify is 256. So in general,
It
these
should be 1024, no? For one byte.
not 20. Sorry, 2 power 8 is 2 power 10 is 1024. Sorry,
Okay.
2 power 8 is 256. 2 power 10 is 1024. Okay, so 2 power 10. 500 and double of this. Okay, 524, is it? 524.
Yes, ma'am. Yes, ma'am.
256, 500,
512.
12, 512, 512.
Well,
After that, 1024. Okay, so 10
Yes.
bits means 1024. We are taking only 8 bits. 8 bit means 256. So, but this 256 also, there may be numbers also, integers or some numerical values also. So when you are taking a numerical values, we accept both positive values and negative values. So that's why among these 8 bits, in general, we use always 1 bit for sign to represent the sign. 1 bit we use it for representing the sign value. That is whether it is a positive number or negative number. Okay, so if the most significant bit, suppose if I say 10, 110, 11, suppose these are the 8 bits. These are the 8 bits. So this is called most significant bit, MSB, whereas this is called least significant bit. Always the MSB bit, we use it for representing the sign. MSB bit, we use it for representing the sign value.
So, ma'am, while calculating the actual complete value of the number, we will include this MSB or not?
No, we won't include. So we will, if it is a signed number, then we will include only up to 7 digits for representing the data. Whereas 8th bit is for sign bit. If the 8th bit is 0, that indicate it is a positive value. Positive value.
Ma'am, and if it is an unsigned number, then we will include all the digits
Yeah,
to calculate.
if it is an unsigned number, we will use all the 8 bits for representing the data, because in the unsigned value, you will have only positive values.
Okay, ma'am. Okay, ma'am.
So 0 means positive, whereas if MSB is 1, that means it is a negative value. So this most significant bit indicates the sign. 0 means positive, 1 means negative. Only these 7 bits are used to represent the data. Okay, so that's why here he is given that we are using a 7-bit ASCII. 7-bit ASCII means each. Actually, here if we are using a MSB 8-bit data and MSB is used for sign, in that case we can able to represent the total 8 bits using 8 bits. You can represent 256 different values. So those values are minus 127 to minus 128 to 127. These are the different 256 values that we can able to represent. Okay, so the total 256 values, these are including 0. Okay, so the two, I said 8 bits can able to represent 256 different values. So these 256 values, what are those 256 values we can represent is minus 128 to 127. So whereas when you are talking in the sense of a character, there won't be any negative. So negative values. Whereas when you are representing a character set of your language, so there you may have something like this. This is also a character, something which is representing using a single quote is called a character. Okay, whereas if I say 3, that is a numeric 3. If I say single quote 3, that is a character 3. So every character will have an equivalent ASCII value in your conversion translating language. Say for example, if I say A, capital A, so it will take the ASCII value as 65. 65 is the value for A. So it will take, when you enter A from the keyboard, so your translator will take the value 65 that is converted into binary, and that binary value will send it to the computer so that it can able to understand you have entered A. Okay. So
Ma'am, you have assumed the 65 is a
65
is the assumed value or
not
it can be taken from
value. So you'll have a ASCII chart. You can in the Google you type ASCII chart. So in the
Okay.
ASCII chart, every character will have a code, integer equivalent code. See, like this. This is the ASCII code character. So, say for example, 65, the capital A is represented using decimal 65. Capital B is 66. Like that, small a is 97. Okay, small b is 98. Like that,
We have
every
to memorize
character,
it.
every character in the keyboard will have equivalent ASCII value. So
Okay.
to represent all the keys that are there in your keyboard, we require minimum 8 bits. Okay, 8 bits
Okay.
means you can able to distinguish 256 different values. Okay, so here
Yes.
he said 7-bit ASCII, not 8-bit ASCII, 7-bit ASCII. So
Okay, ma'am. If the questions may be asked using 7-bit or
yeah,
15, these only
suppose
possible.
you may ask
You
like
can
this.
show another example, ma'am. You can show another
Yeah,
example.
yeah, I'll give you. You may ask
For
like
example, if in place of 7-bit,
hmm,
it said that it is 8-bit.
8.
So,
In that case, it will
the
be
answer will be 32, no?
32. 32 bits. Answer will be
This
32.
is for particular, like for example, in IITM,
Mm.
each I, T, and M, each alphabet will use 7-bit. So
8.
total it
Yeah.
will use 28.
Yes, yes. So here, suppose if he didn't give anything like this, just how many bits are required to encode this string. That's all. In that case, always you have to assume each character will take 8 bits of data.
8 bits. Yes.
Yeah. So in that case, it will be 32 bits. If you are specifically given, it is 7-bit or 5-bit. Even there are some codes, EBCD ID code or some other codes are also there. If you use those codes, even they may take only 5 bits. Okay. So like how many
Remember,
different?
default is 8-bit,
Yeah,
basically.
default is 8-bit. Each character is 8-bit.
Yeah,
Okay.
like ma'am,
So
we use the data. 1
yeah,
KB is equals to 8 bits. 1K. Oh yeah, 1B is equals to 8 bits or something like that. Or 1 MB is
E-
equals to 1 GB is
no,
equals
no,
to
no,
1200.
no, 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 not like that. Not like that. So using 1 bit of one, if you use a memory of 1 byte, you can able to distinguish 256 different values. Suppose
Okay.
if the integer value is, you are representing an integer value, how much big value you can represent is, you can represent maximum integer, which is between minus 128 to 127 only, if you are using 1 byte of data, 1 byte of memory to represent your data. Okay, so you
Okay.
can enter any value between this only. It will not accept if you give 256. Okay, so if you
Yes.
are representing your data using 2 bytes, if you are representing your data using 2 bytes, in that case, it will accept the values between minus 32,768 to 32,767. Any value, any integer between this range, it will accept. If you are
If
using
we use it 2
two,
bits here,
yeah,
data.
2 bytes of memory
Right.
to represent
Right.
your data. So like that,
Okay.
yeah, you have a data types, no? You have a basic data types in C language. Those are char, int, float, double. Okay. So these are the different data, basic data types that are accepted in the C language. So based on what type of data, your data must be any one of this. It can be a character, or it can be integer, or it can be a float value, or it can be a double value. No other type of data will be accepted by your C language. Suppose if you say that your data is a character, if you say that your data is a character, for each character it will take 1 byte of memory. Okay, if you say your data is an integer, so based on your processor capacity, whether it is a 16-bit or 32-bit or 64-bit, so it will take either 4 bytes or 2 bytes. If in the older systems like 16-bit processors, it will take only 2 bytes of memory. But nowadays, most of the systems are 64-bit systems. So in that system, your integer will occupy 4 bytes of memory. Okay, so that means you can represent somewhat larger value. Suppose if in the older system, you can integer means you can give any value between this range only. Suppose if you go for 3 bytes, the range will increase. If you go for 4 bytes, again the range will increase, like that. Okay, so based on how much memory we are using to represent the data, the range will increase. Okay, so but always when you are storing the value in a memory, each memory location will be having some address. At each address, you can store only 1 byte of data. Okay, so at each memory location, you can store only 1 byte of data. So that means, suppose if I have my memory 0002, say FFFF. These are my memory locations. I have a memory of this much. Say for example, if I want to represent an integer, so I said integer is the starting location of integer is 2000. If I say, so that means it will take the 4 memory locations: 2000, 2001, 2002, 2003. So the integer is represented using 4 memory locations: 2002, 2003. Here you can store an integer value. Suppose if I am storing a character, so then only one memory location is, say, suppose my character is stored at a 3000 location, if I say. So one location is enough for the character, because each memory location can represent 1 byte of data. So based on how many bytes will be taken by your data, it will allocate the memory, required memory. So if I want to store an integer data, your system will automatically allocate 4 bytes of data, 4 bytes of memory. Okay. Whereas if you are using a float will also take 4 bytes of memory. So it will allocate 4 bytes. Suppose if we are representing our data using a double data type, then it will give you 8 bytes of data. 8 bytes of data will be allocated to you. So based on which type of data we are representing, so it will allocate the memory. Here we are representing a character data. How many characters? Suppose if you want to represent your name, if you want to store your name, suppose think that your name contains 20 characters. Okay, 20 characters. Then it will allocate 20 bytes of memory. 20 bytes of memory. How we will represent your name is, say, char. Name consists of set of characters, not a single character. How many characters you want, that you need to specify using the size. This is the maximum size. That means in the variable name, you can store maximum of 20 characters. That means it will allocate 20 bytes of data, 20 bytes of memory to store your name. It will allocate 20 bytes of memory to store your name. So based on how we are representing our data, using which data type, based on that, it will say how many bytes it will take. Okay. So here we can say there are 4 characters. Each character will take 1 byte. So 4 characters means 4 into 8, 32 bits. But here we are given that each character is represented using a 7-bit ASCII code. So that means for each character we are using 7 bits. There are 4 characters, 4 into 7, 28 bits.
Yes.
Okay. Next, which component of computer system is responsible for fetching the instructions from memory and executing them? So always the CPU will fetch the instructions from the memory and execute them. Okay. So CPU. What will be done by your RAM? For what purpose we use RAM?
To load and store, to execute fast.
No. So when you want to execute something, so it can be able to, your computer can able to execute your code only when it is in the main memory. Okay. So that main memory is nothing but a RAM. Okay. So if it is there in the secondary storage, like in your hard disk, your computer cannot be able to execute it. Your CPU cannot be able to execute that code. So only when it is moved from your hard disk, if it is moved to the main memory, then only it can able to execute your code. So that main memory is represented using RAM. Okay. Hard disk is your secondary storage. Okay. So these two are for storing the data, whereas this is the one which will fetch the instructions and execute them. So CPU is the answer.
Ma'am, in the previous questions you have to take. If suppose IITM using 7-bit ASCII, you have to mention. If suppose 15-bit means we have to multiply.
Yeah.
4 characters and into multiply with 15 or 10. 10
Yeah.
or 12.
Yeah.
Just we have to multiply.
Suppose yes, actually there are nowadays, like suppose if you use the Java programming language, not the C, Java programming language. In Java, each character is represented using 2 bytes of memory. Okay. So to store IITM, it will require 64 bits.
Okay, ma'am.
Yeah, got it? So in Java language, each character is represented using 2 bytes.
Okay.
So here, another clear instruction is, suppose we are writing a code in only one language, like using English like language, say suppose. So in the English, how many symbols you have, based on that, they will decide each character, how many bytes they need to take. Suppose you are representing the symbols of, say, 7 or 8 languages, say Hindi, Telugu, Tamil, and English. All the language characters, it should accept. Your language should accept all type of character, all the symbols that you have in all the 4 languages. So in that case, 128 different values is not possible. So you may have more symbols. So when there are more symbols, you can't represent more number of symbols using only one byte of data. So in that case, you need to increase the size of your each character.
Okay, ma'am.
If
suppose 15-bit means we have to calculate the byte.
Yeah, but generally they will allocate in terms of byte only, nearby byte. Maybe some of the bits might be unused.
Okay, ma'am.
So 15-bit means 2 bytes, nearly 2 bytes it is. 16 bits means, so 1 bit is for sign and the 15 bits is for data. So you can represent almost 65,535 different symbols in that case. Suppose if you are using a 2 bytes, you can able to represent 65,535 different symbols.
Into multiply with the IITM.
No. I'm not saying like that. 60, like in the IITM, only English letters are there.
Oh, okay.
Only 26.
It's a string.
If it is a capital IITM, it will be 26. If it is a small IITM, another 26. So only 52 different symbols are there in the English language.
Okay.
Suppose you want to recognize your language your C language, it should able to recognize even the language is in Telugu, my program is in Telugu, or my program is in Tamil, or my program is in English, or any language, if it should accept any language program. So in that case, we need to represent your data using somewhat more bits.
Okay, ma'am. Okay.
Got it? But
Got it.
what are the different characters accepted by C language? Only English alphabets, capital A to Z, small a to Z, digits 0 to 9, and some special symbols. So
Understood.
the character set of your C language, to accept all the characters of your character set supported by your C language, we require only 8 bits. Maximum is 8 bits.
Okay, ma'am.
Okay. Suppose if your program is accepting universal language, in that case, even you may require some more bits. Okay. So here we are talking in the sense of C language only. So to represent each character, we are given clearly 7-bit ASCII. So
Okay.
4 different characters is 4 into 7.
Okay, ma'am. Got it.
Okay. Next, consider the following code segment in the C language. We are given 3 variables A, B, X. A and B are initialized with value 1, and X is the output you are calculating. And this is what A plus is equal to B means. It is a shortcut operator. A plus is equal to B means it is a shortcut operator. The meaning of that is A plus equal to B. The meaning of this is A equal to A plus B. When you have the same operand on both sides of equal to, instead of writing it twice, we simply write it like this. This is called shorthand notation. This is called shorthand notation. So the meaning of this implies, the meaning of this is same as this, A equal to A plus B. So what is this statement is saying? You are modifying the A value with A and B, sum of A and B. So A value is 1, B value is 1. So A plus B means 1 plus 1, 2. So now your A is modified with 2. So this says that A value will be modified as 2. Now next, what we are doing? We are calculating the X value. So X is equal to what we are saying, minus, this is a unary minus, indicates the sign. So negative. So A plus 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 B. See here, the plus plus operator is an increment operator. So if I say A plus plus, the meaning of this is A equal to A plus 1. Increment your operand by 1 unit. A plus 1. The meaning of that is so the meaning of that is A equal to A plus 1. Okay. So whereas you can use the increment decrement operators before the operand or after the operand also. You can also write it like this. The meaning of this is also A equal to A plus 1 only. Both are same. Increment and decrement. This post increment, this is called post increment. This is called pre-increment. The meaning of both is same. A equal to increment the operand by 1 unit. But when you are using this value, this increment operator in an expression, it will act differently. It will pre-increment means first the value of A is updated. That updated value is substituted in the expression. Okay. Suppose if you use a post increment, first A value is substituted in the expression, and then after that A gets incremented. Okay, that is the main difference. Post increment means A value is substituted in the expression. After substitution, it will increase. Whereas pre-increment means first A value gets updated, incremented, and that updated value is substituted in the expression. So that is the difference. Only you will find the difference when you are substituting the value in an expression. Okay. So here he has substituted the value of increment operator in the expression. So the first value is A plus plus. A plus plus means post increment. Post increment. That means the current value of A is substituted here. What is the current value of A? 2.
2.
The current value of A is 2. So 2 is substituted in the expression and A will become 3. A will become 3. But the value substituted here will be only 2. Before incrementing, it will substitute. And then the next is for B, we have used pre-increment. That means first B value gets incremented. So B value is 1 now. So it will be incremented. That means it will become 2. B will become 2. And that 2 will be substituted here. After increased value will be substituted here. So this means after executing this statement, your A will be 3 and your B will be 2 because we have used a increment operator here. So that means A value will be incremented by 1. Previous A value is 2. So now A will become 3. So the previous B value is 1. Now B will become 2. So these two will get updated. Whereas while substituting here, which value we need to substitute, that depends on whether we have used a post increment or pre-increment. Post increment means current value is substituted, after that it gets incremented. Whereas the pre-increment means first it will increase the value of the variable and then that increased value it will substitute. So what is the minus 2 plus 2? 0.
0.
So after executing this statement, X value will be 0. X will become
Ma'am,
0.
can you tell me what that equal sign do here? Like
Yes, sign.
after
It will
the-
assign.
Okay.
It will assign the value to variable.
like
It will
A
update the value of
is-
this. Which one you are asking, ma?
After initializing the value A is equals to 1, B is equals to 1, then next.
This statement.
Yes, that one.
This statement. This is a shorthand notation we say. The meaning of this is A equal to A plus B. When you have the same operand that comes on both sides of equal to, so instead of writing that twice, we write it like this. Okay, so this is called a shorthand notation. The meaning of this is A equal to A plus B. Suppose if I write it like this, A minus equal to B. The meaning of this is A equal to A minus B. A is there on both sides of equal to. The meaning of this is A is there on both sides of equal to.
Okay, ma'am.
Okay. So first
Yes.
statement executed is this. That means A, B values are added. So A value is 1, B value is 1. It will be 2. And 2 will be stored in again A. So A is updated with the value 2 here after executing this statement. Then it will come to this statement, X value. It will come to this statement. So in
Hello.
this statement, yes.
Ma'am, suppose A plus plus means A is equal to A plus 1.
Yeah.
But in the question plus B means you have to plus A equal to A is equal to A plus 1.
Plus plus B means B equal to B plus 1.
Okay, ma'am, you have to put plus A.
Say instead of B, you are saying you want to put a plus plus A.
Okay.
Okay. So it both A plus plus or plus plus A, both are same. A equal to A plus 1 only. Okay. But when you are using that in an expression, so how it will work is, pre-increment means first value of that variable is updated, and that updated value is substituted in the expression, pre-increment. Suppose if it is a post-increment, first variable value is substituted in the expression, after that variable value gets incremented. So here we given that A is a post increment. That means first A value substituted here, after that A will become 3. So current A value is 2, so 2 is substituted here, and then A will become 3 after that. Now we can, here the second operator is B. For that you are given plus B, that means pre-increment. So first B value gets updated, B will be 2, and updated value is substituted in the expression. So here it will substitute 2. So minus 2 plus 2 will be 0. So X value will become 0, and A value will be 3, B value will be 2. Anyhow, AB will get incremented by 1. Whether it is in pre-increment or post-increment, whatever it may be, that variable will be incremented by 1. So the X value will be 0. Okay. Next. Which of the following is or not a valid data types in C language? So the basic data types available in the C language is only these 4. Char, int, float, double. Okay. So there is no data type called string. There is no data type called class. So string is nothing but set of characters only. Whereas a class means the equivalent data type in this is a derived data type. We have called a structure. Okay. So these two are not valid data types in C language. Only integer is valid, char is valid.
But we have to use in Java. It's not.
Yeah.
Is it like
Java, these two are the data types. But in C language only we have these 4 data types: char, int, float, double.
Okay.
So consider the following code snippet. Okay. Printf %d. Here you are given, see here, x greater than or equal to y, and x by y equal to double equal to 2. So here first we will evaluate this x greater than or equal to, double equal to. These are the relational operators, relational and equality operators. They will return a Boolean value. Boolean value means true or false. Always they will return a Boolean value. That means that value is true or that value is false. Based on the values of x and y, it will display. Okay. So and means, so and how it will work is, when both condition, this is one condition, this is another condition. When both conditions are true, then and will return true. And of these two conditions will return true. Otherwise, it will return false. Okay. So for which of the following integer values of x and y, the given code snippet prints 0. 0 means false. So the code, it will print 0 if the given answer is false. It will print 1 if it is true. So when the computer need to return to you the true value, it will return 1. Okay. When the computer need to return a false value, it will always give you 0. Whereas when we are giving the input, any non-zero value is taken as true, whereas 0 is taken as false. When we are giving the input, so your computer will accept any non-zero value, something like say 5 or minus 32. Any value which is not 0. is treated as true. 0 is treated as false. When it needs to return the true or false value to us, in that case, to return to say that it is true, it will return 1. To say that it is false, it will return 0. Okay. So remember this.
And why every non-zero value it will return true?
Like in the C language, that is the notation it will follow. Every non-zero value, it will take it as true. 0
Whenever
is taken
condition
as
is true,
There is-
whenever the condition is non-zero, it will print true.
yeah, it will print true. If you are using a logical operator, like a relational operator on that, so it will take any non-zero value as the true. Okay, if you write a condition, something like if 5, if you write if 5, that means it will take true. 5 means non-zero value, so it will take this as a true. If you say
And
if
double
5,
and means the AND gate here.
and yes, double and means and operate, logical and. Say suppose if
And
you are
single
saying,
AND means the address in the value.
no. Single and has so many meanings. When you are reading in the scanf, before the variable, if you say address, that is the address. Suppose if you give a single and, that is binary, like bitwise and operator. Bitwise and operator. So when you are adding two binary values,
Okay.
when you want to perform bitwise AND operation between these two binary values, there we use AND. Okay, AND
Yeah.
has so many meanings.
Or
Based
0 and
on,
1, 0 and yes.
yeah,
True and false, true and
0 and 1 is 0. 1 and 0
0.
is 0.
0.
0 and 1 is 0. 1 and 1 is
0.
1.
1.
1.
Yes.
When both are true, 1 means true. When both are true, you will get the true value.
True answer,
Otherwise,
yes.
you will get the false value. Okay, bitwise operation. If you say you want to perform a bitwise operation, then we use single AND. Whereas this double AND is the logical AND. Logical AND means, so here we are specifying some conditions. Condition 1 and we are condition 2. We have a 2 conditions. Say for example, when both are true, you want to do something. Then we need to combine these 2 conditions with AND. Say for example, so you can able to write a quiz 1 only if you got say in your graded assignments, if you have a more than 40 marks, then only you can able to write a quiz 1. Or suppose in your mock test, if you got above 60, then you are eligible to write quiz 1. If I say either you should get 40% of the marks in the graded assignments or 60% of the marks in the mock test, then only you are
Yes.
eligible to write quiz 1. Okay,
If
either
2 of 1 is
yeah,
true,
if
then
I yeah,
we can give the answer.
if
Or
we
can
if
give
I
we
say,
can give the paper.
yeah, if I say anyone, then we combine those 2 conditions with R. Either this or that. If you combine either any one of the condition is okay. If I say, we will combine those 2 conditions with R. Suppose if I say you are eligible to write quiz 1 only if you got more than 40% in graded assignments and more than 60% in mock, and both conditions must be true to eligible for quiz 1. If I say, then those 2 conditions I need to combine with AND.
Yes.
Okay, if any one of the condition is true to perform something, then we combine them with R. Okay, these are the logical AND and R.
Yes, ma'am. I am familiar with this. I am only gets wonder when I see that and percent in a scanf we use for addressing the values, and here we are using for
Based
logical.
on the place it can able to understand. A scanf and means address of a variable. So whereas in the expressions, it will take AND as a logical bitwise AND. Single and means.
Okay.
Okay. So there will be so many symbols like that, not only and. Star also will have a different meanings. Later you
Yes,
will
ma'am.
encounter. Okay.
Yes.
So like that you will have a different meanings for based on the where we are using. Okay. So here you check out this now. Which of the following integer values of x and y should return the code snippet prints 0? Your answer should be 0. So we'll check all the combinations. If I take x value as 15 and y value as 5, so what happened? 15 greater than or equal to 5 and x by y, x value is 15, 15 by 5 equal to 2. So now if you check this first condition, 15 greater than or equal to 5, which is true. This is true.
Yes.
Okay. So when it is true only, the AND condition, you remember something here. If the first condition is true, then only it will evaluate the second condition. If the first condition itself fails, it won't do this at all. Okay, because
Okay, ma'am. So it will help us to verify the one first.
Yeah.
First.
If the first one itself is wrong, false, then it won't check the second one, because for AND condition, both must be true. Then only it will be true. So by seeing this itself, the whole expression is false. It will decide if the first one is false. Okay. So because the first condition is true, then it will evaluate the second condition. So what is the second condition? 15 by 3 is 15 by 5 is nothing but 3. So 3 equal to 2, which is false. 3 equal to 2 means it is false.
False.
So true and false is false.
Okay.
True and false is false. Final answer is false. So false means it will return 0. So your answer will be printed as 0. So for this first case, the answer will be 0. Now we'll check the second case. Okay. So what is the second case now? You tell me. 10 greater than or equal to 5. So which is true. And then it will evaluate this. 10 by 2, 10 by 5. Sorry, 10 by 5, which is 2. 2 equal to 2. That is also true. So first condition is true as well as second condition is true, and you are combining those two conditions with AND. So AND will also be true. So the final result is true. So that means it will return 1. Okay. So it will print 1. For the second case, it will print 1. But we are asked to select the one which will print 0. So it cannot be the answer. So next one, 5 and 10. So if I say 5 greater than or equal to 10, 5 greater than or equal to 10, and 5 by 10. So now 5 greater than 10 itself is false. This is false. So when the first condition is false, it won't check at all. This condition will not be checked, and directly it will return false. False means 0. Okay. So it won't check this second condition at all. So simply by seeing this, we got that it is false. So AND condition says that if any one of them is false, the result is false. So false, it will return 0. Yeah, this will return 0. Whereas the third one, so 20 greater than or equal to 10, which is true. So it will divide 20 by 10, which is 2. 2 equal to 2 is also true. So you will get true and true. Yeah, true and true you will get. So the final result is true. So you will get, or you will be printed with 1. So this is wrong. So now last one, 10. 10 greater than or equal to 10, which is true. And 10 by 10. 10 by 10 is 1. 1 equal to 2 is false. So this second condition is false. So true and false is false. So you will get 0. So only
Zero,
for
yes.
these 3 cases, only the first, third and fifth cases you will get 0. Whereas for the second and fourth cases you will get 1.
Hello, ma'am.
Yeah. ma'am.
Ma'am, if suppose OR condition means what will do? Show me one example.
Yeah.
If
Suppose,
any one of it is true, then answer is
Yeah.
true.
Okay.
One.
Suppose if it is R, so R condition, R operator, the property of it is any one must be true to get the final answer to be true. And if the first one is itself is true, if the first condition itself is true, then it won't check the second condition. 15 greater than or equal to 5. So because this is true, it won't check this. This second part it won't check.
Okay, ma'am.
This will not be executed. Okay, this will not be executed. So because this is true, R says that any one condition must be true to get the final true value. So it will, based on this, it will decide the answer is true. That means you will get 1.
Okay.
For the first case, you will get 1. Like that.
Not also same like this.
Not means a single unary operator. That means if it is true, it will return false. If it is
False
false,
means
it
it
will
will
return
go. Okay.
unary. It will work on only one operand.
Okay.
Oh, next. What will be the value of the variable x after executing the following code snippet? The answer input must be an integer. Example, the answer, okay. So you have to write an integer value here. So in general, in the quiz 1, you will have either MCQ or MSQ or numerical questions. So MCQ means any one of the answer is correct. Any one of the given options is correct. MSQ means multiple answers might be right. Multiple answers, multi-select question. So multiple answers, something like this. Here, this question is having 3 answers. Whereas here, in this case, you will have only 1 answer. This is MCQ. Whereas this is called MSQ. Whereas this is called a numerical question. So you need to enter some integer value there. Okay. So x value is 8, y value is 3. So what is the expression given to us? Conditional operator is given. Conditional operator, question mark and colon. So how the conditional operator work? Let me explain. A greater than B colon C. So I have written some m equal to, I have written like this. A greater than B colon C. Sorry. A greater than B question mark A colon B. So I have written like this. A greater than B question mark A colon B. So this is called a ternary operator. Question mark and colon is called a ternary operator. That means it requires 3 operands to execute. So this is the first operand, this is the first operand, this is the second operand, and this is the third operand. Okay, so we will have something like this. Expression 1 question mark, expression 2 colon, expression 3. Okay, so 3 operands are required. So first, how it will execute is, first it will evaluate expression 1. It will evaluate expression 1. If the expression 1 is true, if it is true, then expression 2 is your answer. Whatever you have after the question mark will be the answer. If the expression 1 is false, expression 3 is your answer. Okay, so it is simple, like simple if else. This is simple if else. You can write it like this. If exp1, answer is exp2. else answer is exp3. So this is like a simple if else. First it will evaluate expression 1. If the expression 1 is true, then it will execute. Your answer is whatever you have after question mark. So expression 2 is your answer. Suppose if your expression 1 is false, then expression 3 will be your answer. Okay. So according to that, we will evaluate this. Now, what is your expression 1 here? X mod y not equal to 0. X mod y not equal to 0. What is the x value given? 8. Mod y value given 3. So 8 mod 3, you will get a remainder of 2. So what remainder you will get? When you divide 8 with 3, what is the remainder you will get? 2. 2 not equal to 0. So 2 is not equal to 0. So this condition is true. This is true. So when the expression 1 is true, what will be our answer? Whatever we have after question mark. So what we have after question mark? X mod y. So that is nothing but 8 mod 3, which is nothing but 2. So your x value will be 2. Your answer will be 2. Have you got it? How the conditional operator work? First, it will evaluate expression 1. If the expression 1 is true, your answer is expression 2. If your expression 1 is false, your answer is expression 3. So for our case, the expression 1 is true. So our answer will be whatever you have after question mark. After question mark, we have x mod y. So 8 mod 3, which is nothing but 2. So your answer
Ma'am, what is that exclamatory sign do here?
Yes, ma'am. I have this.
This one.
Exclamatory sign.
Above 2 exclamatory means
Not equal to. That is
Okay.
the symbol for not equal to.
Okay, ma'am. Thank you.
So your answer is 2. So conditional operator. This question is based on conditional, how conditional operator will work. Next, what is the range of a value, range of values a signed int type variable can hold in 32-bit architecture? 32-bit architecture means your integer is 4 bytes of memory. 32-bit architecture means 32 bits means 4 bytes. Your integer is taking 4 bytes of memory. Okay. So for here signed integer, signed means it should accept both negative values as well as positive values. So out of 32 bits, when you want to represent both positive and negative, 1 bit is used for sign. 1 bit is used for sign. So the data is represented using only remaining 31 bits. The data is represented only using remaining 31 bits. So how much big number you can represent? 2 power 31. That is the biggest number that you can able to represent. So this number will be from negative to positive side. 2 power 30, 2 power 30 minus 2 power 31 to 2 power 31. Okay. So
we have to take 0 also.
Yeah. So sometimes we will write, we have to always, the 0 is considered towards the positive side only. So 0 is considered on the positive side only. That's why here previously when I write minus 128 to 127, why I have written up to 127? Because 0 is also there in the right hand side and the positive side. So 128 values means 0 to 127 only you will get. That's why we are reducing minus 1 on the right hand side. So when you are talking logically, When you are talking logically, you can say that the range is between 2 power 31 to positive side 2 power 31. I said 256 different values. So what are those 256 different values? Minus 128 to 127, I said. So how you got that 256? 2 power 8. So you can say the range of a sign integer can be minus 2 power 31 to plus 2 power 31, or you can also say minus 2 power 31 to 2 power 31 minus 1 when you include 0. Okay, so both ways of saying is correct. So here, see here, this is inclusive. Square bracket means inclusive, whereas this is excluding. Excluding. So 2 power 31 excluding means you will have up to 2 power 31 minus 1. Bracket. Square bracket means inclusive. Include the last one also. Whereas open bracket means this parenthesis means, like suppose if I say it is in the range of 0 to in the range of 1 to 10, if I say. So if I use a square bracket, 1 can also be there, 10 can also be there. If I say like this, 1 to 10, I have right hand side, I have used parenthesis. That means 1 can be there, 1, 2, 3, etc. up to 9 are there, but 10 cannot be there. Okay. So parenthesis means not inclusive, whereas a square bracket is nothing but inclusive. Consider the code segment in C language given below. X value is 1, Y value is 1, Z value is 0. If X not equal to 0, Y plus plus, Z plus plus. Okay. If Y equal to 0, Z plus plus, else Z minus minus. Printf YZ values. Now we'll evaluate. So if X not equal to 0, what is the X value? 1. 1 not equal to 0. Is it true or false?
Yes. True.
True. So this is true. So when you say something like this, if expression, if some expression value 1, value 2. Whether you write with the tab or without tab, everything is same. Okay. If you write it like this, the meaning of this is, if this expression is true, it will execute only this statement. Single statement will be executed because you have not given a compound statement. This is a simple statement. Suppose if I give it like this, then if this condition is true, both the statements gets executed. Have you got it? If I didn't use curly bracket, if for this expression is there true, then it will execute only this condition, this value. Okay. Immediate statement, a single state, when there is a single statement is to be executed when the given condition is true, then you need not put it in the curly bracket. Otherwise, you need to, if you want to execute all those, you need to put it in the curly bracket. So you have to write it like a simple statement or a compound statement. Okay. So here, let us check check this, how it executes. So x not equal to 0. So which is true? True means it will execute y plus plus, as well as after completion of that it will come to z plus plus. Both gets executed. So y plus plus means y will be incremented by 1. So y value will be 2. So z plus plus means z value will be incremented. So z will become 1.
1, yes.
Z will become 1. Now,
Your voice is not.
my voice is breaking.
Yes.
No, ma'am. Clear.
Slightly.
Still have a problem? You tell me, ma. Once I will log out and log in. No problem. Okay. Still have a problem? Then you inform me. Is there anyone waiting in the queue? So, both, because this condition is true, so it will execute y plus plus, and then in the continuation it will come to the z plus plus. Z will be incremented, and again you are checking the condition. If y equal to 0, is it y equal to 0? Y value is 2, but
Yes,
we are comparing with 0. So it is not equal to 0. So this will be false. This condition is false. False means it won't execute this condition, z plus plus. So it will come to the else part and executes z minus minus. Z minus minus. So that means z value is, now it is 1. So z minus minus means it will become 0.
0.
Yeah, it will be decremented by 1. So z will be 0. So if you print the y and z values, what is the y value? 2, and z value is 0. So it will print 2, 0. Have you got it?
Yes.
Okay. Then consider the code segment in C language given below. So I, j values are initialized to 0. And in the first statement is a loop statement. How it will execute? So let me explain. So first statement will have 3 expressions: expression 1, expression 2, expression 3. You can say condition 1, condition 2, or condition 3, or whatever it may be. So these 3, in general, how we will say for easiness is, the first expression is the initialization. The first expression is the initialization, semicolon, then condition checking, then increment or decrement. This is how we define the first statement. So whatever you are saying in the expression 1, that is nothing but initialization statements. We will write it here. Okay. After that, we write a condition checking. How long we need to execute this? That condition checking, we write it here. So after each iteration, what we want to do, that we will specify in the increment and decrement part. Okay. So, and then whatever code that you want to execute, you can write it in either in a compound statement or a simple statement. If you write a simple statement, only one statement get executed after this. If you write a compound statement, all the statements included between open and closed parentheses gets executed. Okay. So how this will execute is, first it will do this. First, when it enter into the for loop, first it will do the whatever you have here, that gets executed. So this is the first step. You can see this is the first step it executes. After that, it will check the condition. This is the second step. This is the second step. If the condition is true, then it will execute the body of the loop. So this is the third. It will, third step that it execute, whatever you have in the body of the loop, that executes the third step. Again, it will come under, after completion of the third step, it will come here, increment and decrement part. This gets executed. After completion of the body execution, it will come here and this part gets executed. Again, it will check the condition. Okay. So condition is true. As long as the condition is true, so as long as the condition is true, it will be in this loop. Second statement, third part, fourth part. Again, second part. Okay. So it will be in this loop as long as the condition is true. Repeated. This loop gets repeats. So this will repeat as long as condition is true. If the condition is false, it will come out of this for loop. Out of this for loop. Okay. So as long as condition, so step 1, this initialization will be executed only once, first time when it enters into the loop. Whereas condition checking, body loop execution, increment, decrement parts will be repeated as long as this condition is true. When the condition becomes false, it will come out. Okay. So in this execution, we think that before you start this for loop, you have done initialization of your conditional variable. Okay, suppose somewhere here I said a equal to 10. Say a equal to 10. So initialization, whatever initialization I want to do, I've done before this itself. In that case, I can omit this initialization statement. I can simply put a semicolon. I need not write initialization. And think that inside I am checking a condition. If the condition true, I am using a break statement to come out of the loop. So in that case, I doesn't require condition checking, because inside the loop, inside the body of the loop, you are checking the condition. If the condition is true, you are coming out using a break. So in that case, no need of checking the condition here. So if that is the scenario, you can even omit the condition checking. Simply put a semicolon. Suppose in the body itself, you are increasing your conditional variable. Like either increasing or decreasing your conditional variable to reach to nearer to the condition. Then there is no need of increment or decrement also. So the meaning of this is, you can write it like this with the 2 semicolons inside the for loop. The meaning of this is, this will run infinitely. Whatever you have in the body of the loop, that will be run infinitely. Okay. Whereas inside the body, if you have a break statement, it may come out. Okay. So this is the one of the way to put your infinite loop. Okay. So you can write condition, increment, decrement and omit the initialization, or you can write initialization and increment, decrement, omit the condition, or you can omit the increment, decrement and write initialization and condition, or you can write any one or all the 3. Okay. So like that. So here we are given, there is no initialization here. We are not given the initialization. Only condition checking and increment parts are given. Because why he has not given the initialization is, already I is the loop variable here. So I is already initialized to 0 before the for loop itself. So that's why he has omitted the initialization. Zero. Hello.
The code means initialization. Is it?
This is called initialization.
Inside
Equal
for
to.
loop, first starting colon, ma'am. So that's the initialization.
Semicolon means there is no
Semi-
initialization before that.
Okay.
First semicolon means before that there is no initialization.
Okay, ma'am.
Okay.
Because
So
the value I is equal to 0. That's why I'm going to
is
do this.
already given in the previously. So that's why he omitted the initialization.
Okay.
So now the condition is I less than 10. So what is the I value? 0. So condition is 0 less than 10. So the condition is true now. Condition is true. The condition is true. So what it will do? It has to execute the body. What is the body given here? J equal to I. Okay. So I'm writing all the variables here. I. Okay. I value. And condition. What is the condition? I less than 10 is the condition. Okay. And then J value. And my output also. Let me write output also. So what is the initial I value? 0. So condition, what is the condition? 0 less than 10.
True.
What is the condition? 0 less than 10. The condition is true.
Yes.
The condition is true. So if the condition is true, it will execute the body of the loop. So body is changing the J value. So J equal to I. What is the I value? 0. So J value will become 0. Okay. And then it will get increment the I value by 1. So because this increment decrement part, you have I plus plus means I will be incremented by 1. Okay. So there is no output in the loop. So next again it will check the condition 1 less than 10. So which is true. So it will initialize the I value to J. So J is initialized with I value. I value is now 1. So J will become 1. So and then I get incremented 2 less than 10. 2 less than 10. So J will be 2. So like that, how long it will go? Say 9. I is 9. So 9 less than 10. So which is true. So J value will be 9. And then I becomes 10. 10 less than 10, which is false.
Condition is false. Yes.
False, it will stop. It will stop. It won't execute this statement in that case. So by the time it comes out of the loop, what is the I value? 10. What is the J value? 9. So the I and J values are 10, 9. Okay. So the output is 10 and 9.
Ma'am, first
Yeah.
I is equals to J, and after that I will be add 1.
Yes. First J equal to I. First it will allocate J equal to I. After that I gets incremented. So this
Okay.
is the body. This is the body. J equal to I is the body. Body of your
Okay.
for loop. After executing the body, it will increment the I value. I
Okay.
said no.
Suppose I plus plus means I is equal to
I plus 1.
I plus
that's a
1.
formula.
I equal to I plus 1. Whether you give plus plus I or I plus plus, everything will work in the same in the for loop. I value
ma'am.
gets incremented by 1.
Okay, ma'am.
Okay. Next, consider the following code snippet where x is an integer. Okay. So if x greater than 2, x greater than 2, x equal to x into 2. If x greater than 4, x equal to 0. Printf x. Which of the following statement is true? X will always be 0 after execution of this code for any value of x. So let us test. For any value of test, we will test this by taking x value less than 2 and x value between 2 and 4, x value greater than 4. We need to check all the cases. So let us take x value is 1. Okay, we will check x value. I am taking it as a 1. So with x value 1, we will check this. So 1 greater than 2, false. So false means it won't execute this statement. So it will come and check here. So what is the second condition? 1 greater than 4. That is also false.
False.
Okay.
Yes.
So it won't execute this also. So in that case, it will print the x value as 1. 1 is the output.
1.
So
Yes.
this statement is wrong. X will always be 0 after execution of this code. Whatever may be the value of x, that statement is wrong, we can say, because we got the answer as 1 here. Okay, so it will not be 0 always. So second statement, if you see, if x is greater than 2, the value of x will always be doubled after execution of this code. So let us check. So the possible values in this case can be, x value can be greater than 2 is said. So 3, it can be 3, which is less than 4, or it can be 5, which is even more than 4. 3 or 4. So we will check for those two cases. So 3 greater than 2. So first we'll check it with 3, x value as 3. So if 3 greater than 2, which is true, so then x will be x into 2. So 3 into 2 means x will
6.
become 6. So when it is 6, 6 greater than 4, which is true. 6
Yes.
greater than 4, which is true. So x value will become 0. X equal to 0. Okay. So
If
in this
value
case,
of x is greater than 4, then x is equals to 0, according to the condition.
for this case where x value is between 2 and 4. So let us check this case also. X value is more than 5 if you take. So 5 greater than 2 is true. So x will become 5 into 2, which is 10.
10. Yes.
And 10 greater than 4, which is true.
4.
So x will be
Also
0.
true.
So if x value is greater than 2, whatever might be the value of x, the x will be 0. If x greater than 2, the value of x will always be doubled after execution of this code. So it is not doubling. What happens? X is becoming 0. So your answer is becoming 0. It is not becoming double. So this is wrong. Second option is also wrong. Have you got it? If x is greater
Yes,
than 2, what answer we are getting? Always we are getting 0. But here he said it is becoming double. No. Next, third case. If x is greater than 2, x will always be 0 after execution of this code. That is what we got. So this is true. If x is greater than 2, we are always getting the value of x as 0. So if last condition, if x will always be doubled after execution of this code for any value of x, that is also wrong. Okay, so this condition is true. If x is greater than 2, then your answer will be 0. X will be 0 after execution of that code. Next question. X value 5, y value 0. And while loop, how the while loop will execute? While condition, so it will be like this. While condition or expression. Okay. These are smaller case letters. Okay. So this is the body of the loop. So as long as this condition is true, it will execute the body. Once it completes the body execution, again it will come and check the condition. As long as condition is true, it will execute the body. So body will be repeated as long as condition is true. When the condition becomes false, it will come out of the loop. So in that way, while loop will execute. So here is saying x value 5. So what is the condition here? X greater than 0 is the condition. Okay. So what is the x value and what is the y value? So take what are the different variables you have? Take all those. So what is the initial value of x? 0. And it is, sorry, initial value of x is 5. And it is checking the condition now. So 5 greater than 0. 5 greater than 0. It is true. True means it will enter into the body. And body is saying y is equal to y plus x. What is the y value? 0.
Y
What
is
is
0.
the x value? 5. So
5.
0 plus 5, which is equal to 5. So y will become 5. Okay. And then x will become x minus minus. So x will become 4.
Ma'am, this
Decrement
condition
operator.
y plus is equals to x. That means y plus.
Y is equal to y plus x.
Okay.
Y is there on both sides of equal to.
Okay.
Y is equal to y plus x.
Is equals to x.
Yeah, y plus is equal to x implies y is equal to y plus x.
Okay.
The meaning of that is it. So now x minus minus means the decrement operator. So x will be decremented by 1. So it will become 4. As 4 greater than 0, again it will check the condition. This is true. So it will calculate y value as previously you have 5 plus x value is 4. So it will become 9 now. So then x will be 3. So 3 greater than 0. So 9 plus 3, which is equal to 12. So it will be 2. 2 greater than 0. So 12 plus 2, which is equal to 14. So, sorry. Then x will be 1. So 1 greater than 0, which is true. So it will be 14 plus 1, which is equal to 15. Then it will become 0. So 0 greater than 0 is false. It will stop. So by the time it stops, what is the answer we are asking? What will be the value of y after executing the below C code? So what is the value of y now? 15. So by the time it comes out of this loop, what is the y value? 15. So answer is 15. So the answer is 50. Okay. Next, what is the output of the following C code? So again, a for loop. So how the for loop executes? First, I value will be initialized to 0. So I is there. And what is the condition? I less than 5 is the condition.
I plus
And
plus
I
I
value is
increment.
increased. Okay. So only I is the variable we have. Okay. So let us take what is the initial value of I? 0. What is the condition? 0 less than 5, which is
5.
true. True. 0 less than 5 is true. So here we have a compound statement. Compound. Body is the compound statement. Okay. So now it
Curly braces
again.
means compound statement.
Yes.
Okay.
So again inside the body, it is checking I equal to 2. Is it I equal to 2?
No, ma'am.
Okay. So 0 equal to 2. So which is false. False means it won't execute, discontinue. Okay. So it will come to this statement and the output what is the output that we are getting? Print I value. So the output will be 0.
0. Because condition is
Then,
false.
yeah. So all these, after executing all these statements, this is the closing of your compound statement. So it will go and execute this I++ now. It will execute I++ now. So I will be 1 now. So 1 less than 5, which is true.
Yes.
So it will check 1 equal to 2. Is it true? No, false. So it won't execute continue. So it will execute output is 1. Then it will become 2. So 2 less than 5, which is true. It will enter into the body. 2 equal to 2, which is true. True means it will execute continue. What the continue will do is, see here.
Print the value of I.
No. When we see, when we have a loops, each time when you enter into the body, that is called one iteration. That is called one iteration. So here, so this is iteration 0, and this is iteration 1, iteration 2. Like that, we have written a loop to execute for 5 iterations, say for example. So whenever you encounter a continue, while executing, whenever you encounter a continue, it will bypass the remaining statements of the current iteration, and it will again go to the beginning of the loop. Like it will go and increment the next value. So it will go to the next iteration. Okay. So when you encounter continue, it will bypass the remaining statements of the current iteration, and it will go to the next iteration. Okay. So what are the current in this iteration? What are the remaining statements? This printf statement. You left out with this printf statement that will not be executed. When continue comes, it will bypass this, and it will go to the next iteration, means I gets incremented. So because this condition is true, so simply it will bypass that print statement, and it will increment the I value. So it will be 3. Okay. So the no output will be printed there. So 3 less than 5, which is true. So 3 equal to 5, 2 is false. So it won't go to the continue. So the value printed here is the I value. So it will be printing 3. So now I will become 4. So 4 less than 5, which is also true. 4 equal to 2 is false. So it won't execute continue. I value printed is 4. Then it will become 5. 5 less than 5, which is true. False. It will stop. By the time it stops, what is the output you got? 0, 1, 3, 4. What is the output you got? 0, 1, 3, 4. Okay.
And the condition it satisfies 2 is equals to 2, it not print that value.
Not the meaning of that is continue. Whenever continue comes, how many statements you have after that in that iteration, all those will be bypassed. It won't execute all those. It will go to the next iteration.
And then, for example, if there was break, so it will stop the function completely.
Yes. So continue means it will bypass the current remaining statements of the current iteration.
After 2,
if
we
it is
take
a break,
and 4.
After
2, like a 2 is the our I is equals to 2. Then it bypass the 2 and starts with 3.
3, yes. So
Yes.
If it is a break, it will bypass the entire remaining loop. Okay. If it is continue, it will bypass the remaining statements of current iteration and go to the next iteration. Whereas if it is a break, it will bypass the remaining iterations. All the remaining iterations, it will bypass. That means, say for example, instead of this continue, if you have a break, so here your output will be, it won't execute these iterations. Okay. So your output will be in that case 0 and 1 only. It will come out of the loop. When a break comes, it will come out of the loop. It will bypass the remaining iterations. It won't do. So actually we have written a loop here to execute for 5 times. That means 5 iterations should be there. So, but after second iteration, we got continue. So the remaining statements of the second iteration will be bypassed. That means the remaining statement is printf statement. So that will not execute. So when I equal to 2, it will not execute this printf. Whereas it will go for the next iteration. 3, 4, 5, those it will execute. Whereas if it is a break, even it won't execute the remaining iterations. It will come out of the loop. Okay.
Okay.
So continue means it will bypass the remaining statements of current iteration. Break means it will bypass the remaining iterations. That is the exact definition. Okay. So consider the following code segment in C language. So A, B, C, D, X are given. So this is called a multiple initialization at a once. That means A value will be initialized with 2, B value will also be initialized with 2, and C value will also be initialized with 2, D value will also be initialized with 2. Or in another way, we can say it like this. This is equal to operator. Equal to operator will be executed from right to left. The associativity is from right to left. First, D will be initialized with 2. Next, it will execute C is equal to D. Next, it executes B is equal to C. Then it will execute A is equal to B. So this is almost equal to writing 4 statements.
And ma'am, if we start just opposite, like 2 is equals to A is equals to B is equals to C.
You cannot write a constant value before the equal to.
Okay.
Always the before the equal to you should have variable only.
Okay.
You cannot write it like this. 2 is equal to X. You cannot write. Okay.
Okay,
so you can say always before the equal to you should have variable only, not constant.
Okay.
So next, what are the A, B, C, D values after this? All are 2. All are 2.
2.
Now, yes, how this statement get executed? Now you tell me. So first, this part gets executed because this is also initialization equal to operator only. So assignment operator will always execute from right to left. So first it will execute C plus equal to D. So the meaning is C is equal to C plus D. So what is the
So C will be 4.
4.
Yeah, C will be 4. Okay. Then it will execute B is equal
B
to
equal B plus C.
So then B will be
6.
6. Then it will execute A is equal to
A plus B.
A plus B.
So ma'am, A will be 8.
A will be 8.
Yes.
Okay. So next we are evaluating X value. So what is X? X equal to A.
I think X will be 10.
8 plus C value is 4 mod B value is 2. Is it 2? Yes. B value is 2 minus
No
D
ma'am, B
value.
value is 6.
Sorry. B value is 6 minus D value is 2.
It's 2.
D value is 2. Okay. So this is how we do. So when we are evaluating the expressions, the highest precedence operator among the plus, minus, and percentage is percentage symbol.
Percentage.
So first it will evaluate this. So it will be 8 8 plus 4 by 6, it can't divide. So the remainder will be 4 only.
4.
So 0 times it will go. So the remainder will be 4 minus 2.
So ma'am,
So
it will be 10.
yeah. So among the plus and minus, both are having same precedence. Same precedence. So then it will check the associativity, whether we need to execute from left to right or right to left.
To left.
For arithmetic operators, the associativity is from left to right. So first it will evaluate 8 plus 4, that is 12 minus 2.
Minus
So
2
then it will
equals to
execute
10.
12 minus 2, which is 10. So you have to evaluate always one operator only at a time, one operator only. Which operator we need to evaluate? We need to decide based on associativity and precedence. First we check the precedence. If the precedence is same, then we check the associativity. If the precedence is different, highest precedence operator is performed first, the least precedence operator is performed next. Okay, see here, among the plus, minus and the modulus, highest precedence is for modulus. So we have performed modulus first. Now we left out with two operators, plus and minus. Both have same precedence. In that case, we go for associativity. Associativity always says whether we need to execute that from left to right or right to left. So arithmetic operators, for arithmetic operators, associativity is left to right. Whereas for assignment operator, associativity is right to left. That's why in the previous case, we have executed from right side to the left side. Okay, whereas here from left side to the right side. So first we evaluate 8 plus 4 because plus comes first on the left hand side. So 12 minus 2 is 10. So the answer, the x value, what was asked? Print the x value. So x value is 10. So x is equal to 10. Okay. How many times will the following C code print hello C? Okay. How many times hello C is executed? So let us execute step by step. So this is inner loop. Inside one for loop, you have another for loop. So outer for loop is written to execute for 5 times because 0 less than 10, 5, I plus plus. So I will quickly write what are the possible values for I. So first it will be 0, next it will be 1, next it will be 2, next it will be 3, next it will be 4, next it will be 5. When it becomes 5, it will stop. Okay. So by the time it will execute for 5 times, 0, 1, 2, 3, 4. 5 times it will execute. I. These are the possible values for I. Now let me check the possible J values. So J is an inner loop. So when I equal to 0, so J will be execute the complete loop. So what are the possible values for J? It is starting from 5. It is starting from 5 and it is executing 5 greater than 1. So that means it is executing 5 greater than 0 first time. Okay, and J will become next time it will be 4 because J minus minus 4 greater than 0. Then it will become 3, 3 greater than 0. Then it will be 2, 2 greater than 0. Then it will be 1, 1 greater than 0. All these are the true cases that it executes. When it becomes 0, it will stop. 0 greater than 0 will be stopped. Okay. So for when I value is 0, these are the possible values for J. Then, so for all the true cases, it will be executing hello C. This will be printed. Hello C will be printed. Okay. So here I'm just writing H. So hello will be printed. This case also hello will be printed. This case also hello will be printed. So this case also hello will be printed. This case also hello will be printed. Whereas this is the false case, it will come out of this J loop. It will come out of this J loop. This is the closing of J. So J loop will be closed and then it will increment the I value. So then I will become 1 now. So what are the possible? Previously I value 0. I plus plus means I will become now 1. When is I is 1, again the J will start from 5. So that means 5 greater than 1. 5 greater than 1. 4 greater than 1. 3 greater than 1. 2 greater than 1. And 1 greater than 1. When 1 greater than 1, it will be false. So how many times it will print hello? For all the true cases. 4 times this is true. So it will print hello 4 times here. So the same way, can you tell me when I equal to 2, how many times it will print? How many times it will print? 3 times. When I is equal to 3, 2 times.
2 times.
Okay. When I
Yes.
equal to 4, 1
1
time.
time.
When I equal to 5, false and then come out.
0.
So by that time, how many times hello C is printed? 5 plus 4 plus 3 plus 2 plus 1.
I'm 15. 15.
So 15 times hello C is printed. Have you got it?
Yes, ma'am.
Yeah. So it will be,
Ma'am, is there any trick to save our time during the exam?
yeah, by seeing here, I didn't done all this. So only by seeing the first
Yes.
2 cases, I have assumed this. You have to play that trick.
Okay.
You need to know how many times this loop is executing.
Ma'am.
Then you can evaluate that. So outer loop is executing for 5 times. Outer loop is executing for 5 times into how many times the inner loop is executing.
4
Okay.
times.
Say for example, so for the first case it is 5. Next case it is like, suppose if I say this is also 0. Suppose J greater than 0. Instead of I, if you say J greater than 0. So in that case, that will also execute 5 times. 5 into 5, 25 it will be.
Yes.
Yeah, you have to evaluate like that. So here 5 into, you need to, first time how many times? 5 times it is executed. So in this case, you have to count it separately only. First time it has executed 5 times. Next time it has executed 4 times. Next 3. So 1 plus 2 plus 3. N into n plus 1 by 2. 5 into 6 by 2. 15. So which of the following are valid type of operators in C? So bitwise operators. What are the bitwise operators we have?
And or and
Yeah. Bitwise and, bitwise OR, bitwise XOR, XOR. Okay. So left shift, right shift, all these are bitwise operators. Okay.
Okay.
Then
Yes.
logical operators and or not. These are the logical operators. Assignment operators, equal to, and even all the shorthand notations, plus equal to, minus equal to. So like that, all shorthand operators are assignment operators. So all these are valid operators in C language. All of them. Next, consider decimal number 108. What is the 8-bit binary representation of it? Okay. So you are given one number. So that is 108. So you are asked to represent this value, the equivalent value in binary. Okay. So
Okay.
what, how will you get is you divide this with 2,
Two.
because
Yes.
binary number system, for the binary number system, the base is 2. So one not, oh, sorry. Okay, 108. Okay, so divide this with 2, because binary number system base is 2. So to convert it into the required format, you divide with that base. So it will be 5,
Four.
4, and the remainder will be 0. Write the remainder after division. So again you do it. 2, 2, 7.
8, 2.
The
7.
remainder
Yes,
is
right.
0.
Right.
Wait, anyone is waiting in the. So again, divide this with the 2. It will be 1, 3. Remainder will be 1.
3.
Again, you divide
1.
with the 2.
Yes.
So, ma'am, is there any particular week which we have to give priority for our quiz one?
Is there anything?
Sir, ma'am, from week 1 to week 4, which week has will be more weightage or more important for quiz one?
Definitely third and fourth weeks, because the whatever we discuss in the first and second weeks, those concepts will also be interpreted in the programming. Okay, so might be in the first week you might be learning about the structure of C language and all.
Yes, sir.
So that structure will be there in each and every program. So definitely whatever you are covering in the week 1 will be there in the week 3 and 4 also. And in the
And
week
ma'am,
2,
week 2. Yes.
yes, this type of conversions. So generally, all the weeks will have the same weightage, we can say, but you like while giving the programming questions, we will cover the unit 1 concept also, but you will feel that that question is from unit 3 or unit 4, week 3 or week 4.
Okay, ma'am.
But
Okay.
the question which we give there will be based on the topics that we have covered in the concepts of the week 1 or week 2. So mostly all are same weightage, but when in your sense, if you say 3 and 4 will be having more weightage,
So
especially
it will be
4 is
fine, ma'am,
having,
if
it
we
will,
watch the summarization of week 3 and week 4.
Okay, ma'am.
It is important.
week 4 is very, very important, because week 4 will
Okay.
also cover week 3.
Okay.
Basic data types, initializations, operators, everything it will cover in the week, because week 4 programming will contain week 3 also. Okay.
Okay.
So week 4 is most important. But week
Slightly
to
higher weightage.
solve week 4, you require week 3. Okay.
Okay.
To solve week 4, you require week 3.
Okay, ma'am.
But in our sense, all weeks are having same weightage. We will cover each and every concept. Even though we are asking the question programmatically, that concept we will take it from each unit. Okay. So till you get a 0.
We get 0
as the
when we divide by
coefficient,
2, 3.
it will be 1. Now write the reminders in the reverse order. So it will be 1, 1, 0, 1, 1, 0, 0. But we are
I
asked
think
to
there is
represent it
one
using
mistake.
8 bits. Yes.
Yeah. We can't
Where is the
divide that
mistake?
3 by 2. So it will be 1 maybe.
We can divide 3 by 2. It will be 1 time and the remainder will be 1. And 1 cannot be
Okay.
divided, so 0 times and the remainder will be 1. 1 cannot be
Like-
divided by 2. So that means 0 times it will, quotient is 0, remainder is 1.
Okay.
So you will get 110, 1100. But here we have only 7 bits. We are asked to represent it in the 8 bits. So
8
we
bits.
will, initially we will add 0. This preceding
yes.
0 doesn't have any value. So we will. So this is the answer. 0, 110, 1100. 0, 110, 1100. Okay. Now, so you are given a binary value and you are asked to convert into hexadecimal. So I already told you. So
By
each
4
yeah, you each because hexadecimal means 16. 16 is nothing but 2 power 4. 2 power
Yes.
4 means each hexadecimal digit is to be represented using 4 bits in binary. So you divide the given binary number with 4 bits each and
Yes.
write equivalent hexadecimal value. So now you tell me this value. What is this value? Double, like from the right hand side, we need to slit it from the right hand side. Okay. So first slit is 1011. Okay, this is the first slit. Then next four bits. The next 4 bits is 1001. Okay.
Yes.
1001. This is the second slit. Then the third slit will be 1101.
Yes.
1101.
101.
And the next one is only we left out with 1.
1. So we
1.
can take 0.
So we can take zeros, preceding zeros. Okay. So now what is the hexadecimal equivalent of this? It is nothing but 1. What is this?
Yes.
8 plus 4 plus 1. 8 plus
Plus
4
1.
plus 1. 13.
13.
13 means 10 is A, 11 is
Yes.
B, 12 is C, 13 is D.
D.
13 means D.
Yes.
Okay. Next one is 8
And
plus
this is
1.
9.
9. So this is 9. And this is 8 plus 2 plus 1. 11. 11 means B.
Yes, 11. B. Yes.
B. So 1D,
9B.
9E. 9B. 1D, 9B.
B. Yes.
Okay. So that is the hexadecimal equivalent of this byte.
Binary decision.
Okay. So in the first unit, you will have main components. What are the different components of your computer and what is the functionality of each component? Memory unit, control unit, and your CPU, central processing unit, and your input-output devices. And in the second unit, we are going to cover the number system. How to convert, what are the different number systems supported in C language, and how to convert one number system into another number system, and how to represent the signed magnitude values, like negative numbers, how to represent it, positive values, how to represent it. So how to perform additions and subtractions. So that we will do binary addition, subtractions. How will you do it? That we will cover it in second unit, second week. Whereas in the third week, operators, like what are the different data types in C language, and how to declare variables, how to read and write, how to read the variables, scanf statement, and how to display the variables, that is printf statement. And for processing, we use a formula based, that is writing an expression. So you can write the expression using operators. What are the different operators available in the C language? So how those operators will work. So that is covered in the third unit. Whereas when it comes to the fourth unit, like third week, when it comes to the fourth week, we will cover the control statements. If, switch, while, loops, while, for, do while, and conditional statements like continue, break. Okay, how all these will function. Okay,
In week 4.
conditional, yes, conditional controls as well as loop controls. Okay, conditional controls are if and switch. Like I think in the mock we didn't encounter any switch statement, but in general you will have switch statement programs also. Okay, whereas I think we didn't cover any switch statement here. Okay, we encounter only if, while, for, do while also not come. But in your exam you can expect that also. And here also nowhere we used a break. There we can use break. Only continue come. Okay, so the concepts that you need to cover in the fourth unit is if, switch, all the three loops, for, while, do while, and then break and continue. Okay, the functionality of all these you need to know. So by using them,
Okay.
you should be able to write a small programs, practice small programs, so that program logic only you will get it here. You may given a small program, and you may ask it whether this program will do, whether it will find the factors of the given number, or whether it will check the given number is prime or not. Even options you can get it like that.
Okay, ma'am.
Yes.
Thank you. Thank you, ma'am.
Ma'am, you are also the instructor for
System commands.
system commands.
Yeah, introduction to Linux
Yes,
and
okay.
system commands.
Yeah, Linux systems. Yes.
Yeah, Monday class, summary class I'll take.
Yes, ma'am.
Yeah. Okay. So can I?
Okay, ma'am. Thank you.
Stop?
It's very helpful, ma'am.
Okay.
Thank you, ma'am.
Okay. Good night.
Bye.
Bye, ma'am.
Thank you, ma'am.